to a close. All right, I am sharing the screen. Okay, but now you guys know when I'm talking to myself in these videos and I say, oh, I gotta hold on, I gotta move myself out of the way, and you guys just see me frozen there. You see now I can't see the question. So I gotta move myself so that I can do this problem. Now you see the magic of Hollywood. Are you amazed? Okay, um, so this -10 here compared to x squared. So that's going to move me in what direction? It'll move me to the right 10. It'll move me up 8. Okay. Right 10, up 8. And the new vertex would be to the right 10, which makes positive 10 for the x, 8 for the y, because the vertex of this would be the original vertex is 0, 0. Okay. Questions on that? If I go too fast forward, just raise your hand. I'll turn it back to where we were. Okay, parent function f of x, x to the third power, vertically stretched by a factor of 8. Translated 6 units left. So factor of 8, that's going to mean I'm multiplying by 8. 6 units left, that means I'm going to add 6. 9 units down, that means I'm going to subtract 9. Now, I really recommend you using the transformation rules sheet that you have. Because if you're not sure exactly where vertically stretched comes from, literally look for the words vertical stretch. And you'll find it on that sheet, gives you an A value. So that 8 for, this we'll call it G of X. G of X, the 8 is going to go out in front. To go 6 units to the left, I need to go on the inside and do the opposite, which is to add 6. I still need to cube this, and it's going to go 9 units down. So on the outside of that, subtract 9. And it wouldn't be a vertex here, but the turning point would be -6, -9. What we mean by a turning point is like on a cubic graph, this would be like an example of a turning point. And now you guys can see me nervously check and make sure that I'm still recording and be nervous that this whole time I've been working, I haven't been recording. Making sure. Pretty sure I'm recording still. Hope so. Okay. All right. Again, see my face is in the middle. You're watching the video in the future. You can be like, why is he talking about that? This is blocking my view, so I gotta move it. So which transformations? Okay, so we're going from the solid, and pay attention on the test, like what it asks you, which one is the transformation and which one is the original. In this case, the original is the solid line, which is your standard parabola. So to me, I'm thinking, okay, this flipped. And how would I flip it? I would have to turn positives into negatives. Okay. It also moved to the right 2. how would I accomplish that? I need to subtract 2 on the inside, and then this vertex is at 5, so it went up 5. Okay, so I know there's multiple choice options, but they're all going to look good for a different reason. So I like to write this down so I know that I'm looking for a negative out in front. Do I have any options with negatives out in front? The heck? So you guys didn't have any good options, did you? Okay, so let's just look for right 2 up 5. This is the only one with right 2 up 5. But this should have said, because I got a flip there, it should have had a negative there as well. That's weird. So that's a bad question. It should have had an option that flipped our y values negatively. Make sure to change that for next year. All right, I would just say go transformation by transformation here. The negative is going to reflect us over the x-axis. Yeah, I'll get fancy here. This blue is reflecting over the x-axis. We've used the word flip a lot with that. I'll just put each transformation in a different color. The +1 here, I know I'm skipping the half. I want to come back to that in a second. Okay, the +1 is going to move me to the left 1. This -3 is going to move me down 3. And this 1/2 here, oh, shoot, I hate when that line appears. When that 1/2 is there, if a large number makes me skinnier, then a fraction is going to make it wider. So you could say it's going to be 2 times as wide. There's a couple different options for that. 2 times as wide. It's a fraction, so we could say it's a vertical compression of 1/2. You could also say it's going half as fast. Right, so it would be a wider parabola. Questions on that? Oh, watch this. I'm watching you. Or am I watching you? Wait, that's opposite. You or you in the back. Are we paying attention at that table? Hey, I was told I said I was talking to you. Front and center. Center, center. My left, but the screen's right. Center. I'm very amused by very simple technology things, as you can see. And if someone's just watching this video, they're like, what is he talking about? Because the video is just in one spot. So at home, I'm moving my face like this. Okay, ball hit in the air. The height after is modeled by the equation right down here. Okay. If we went on the same path, but it was hit 3 seconds after. So think about if let's just say we were measuring when a ball was hit, and it's hit the very first time it's hit just like this. Then someone sees that and is like, oh, cool. I want to hit a ball too. But that person was like 3 seconds too late. So they're going to move to the right three. They're still going to have the same peak. It's still going to go just as high. It's just happening. Everything's happening 3 seconds later. So how would we accomplish that? Well, how do we go to the right by 3? That's the question. Okay. We go inside or outside along the x-axis? Inside or outside the parentheses, usually. Inside, right? So we need to go inside the parentheses wherever you see, in this case, it's a t axis, right? The time is measured here. So any place you see a t, we need to go to the right 3. Remember, x's do the opposite. So it's going to be every time you have an x, or in this case a t, you're going to need to take 3 away from it. And that'll make it go 3 seconds later. So these first two, they don't even look close to right. Well, I guess they added 3 to the end. That would move us up and down if you just moved it onto the end there. Okay, but we're trying to just move to the right. The ball getting hit just as high, it's getting hit just as far. It's just that it's happening 3 seconds later. Okay, we said to the right 3, it's tempting to want to add 3, but because the x's do the opposite, every place you see an x, you need to take 3 away, which is what letter D does. Oh, let's see if this video gets taken down for sponsors. Man, when I'm teaching and my voice gets kind of hoarse and dry, I just reach not for any water, but for a LaCroix sparkled water. You know what I mean? It's just a natural feel, smooth, and then I can carry on with my day. The non the LaCroix, what I love about the LaCroix mojito flavor is that I'm just transferred to a beach suddenly in my mind, and the drudgery of teaching sometimes goes away. So if you're studying at home and you're looking for a boost, grab a LaCroix. It doesn't taste like carbonated spit. It tastes good. Remember, that's what I said. It doesn't taste like LaCroix for all your math needs. Do you think we'll get pulled? Do you think we'll get pulled, or do you think we'll get money for that?
Money.
How about neither? Probably neither. I mean, I could get tens and tens of views because of that. Yes. Which one? This one, I'm not a, I mean, I can't believe that. This tastes delicious. So I get sick of drinking water. Like I know you're supposed to hydrate and stuff, but I get sick of drinking water because it doesn't taste like anything. So that's where LaCroix comes in handy because then I'm like the drudgery of drinking no longer. Now I can actually taste something because juice is too sugary, right? And then carbonated things, they taste good, but they're gonna leave you a little too hyped up, maybe. No calories in this. So when you actually do get to the beach, that waistline's ready for it. Right? Yeah. Okay. Back to the scheduled program. When we are at a bakery overnight, thermostat set to 65 degrees. Okay, so that's what this is measuring. This is saying, okay, this bakery, it is 65 degrees at night. When no one is there, it's just like your regular heat, right? Um, and then someone goes in there at 5 a.m., turns on all the ovens, bakes donuts, pretzels, all that other good stuff. And from 5 a.m. until 6 a.m., the heat goes up in the bakery. Okay. Once it reaches 85 degrees, after everything's being cooked, that's pretty much when the bakery can start turning the things off and the heat stays on. And then at 10 a.m., after all the cooking's done and they're just selling stuff, the temperature goes down back to 65, where it remains until the next day when they're baking again. Okay, Andre says, when the bakery starts baking 2 hours earlier. So if at first we started baking at what time? 5 a.m., right? I heard it out there. I know you can't in YouTube land. Okay, but someone said 5. Okay, what does it look like? What time are we baking on this second graph? What time did it start baking? 3 a.m. Okay. So Andre says the bakery started baking 2 hours earlier. That means I need to subtract 2 from the x. Well, is that true? To move to the left, do we subtract 2 from the x? Do x's listen? No. Subtracting 2 and you think, yeah, that's going to move me to the left, right? But x's don't listen. It does the opposite. So what does Andre actually need to do? To move left on x axis, need to do the opposite. Because x's don't listen. You didn't listen to them either. It's not just one person's fault. Everybody contributed to the demise of this. Okay, so instead of subtracting 2, what should we do for this? G of x needs to do x plus 2. So you need to add 2 on x axis to move left. One day I'll understand necessarily why that is, but it's just how it is. Isn't that right? Middle right row. Do you agree? Oh, it's like the opposite, right? When I move it left, it goes to my right. Right front row center, right center center. Correct back. It's too much fun. I think if I there's an old board that I would use. If you throw it, it would bounce off the walls. The video would bounce. Did you now? Thank you. Okay, let's look at f. This question was looking at f of x. Okay, so let's compare these. What is different? All right. Your original graph, when did it open? Opened at 5 a.m. This new graph, f of x, when does it open? 6 a.m. So let's think to ourselves 1 hour later. Max temperature of the original was, what was the max temperature of the original? Temperature, 85 degrees. What was the max temperature down here on the second one? What was the difference there? So it should be 5 degrees warmer, aka plus 5 on the y-axis. So to accomplish f of x, we need to take our original equation. We've got h. I'm leaving gaps here. If I need to add 5 on the y-axis, where is that 5 going to be added? Inside or outside? If I need to move up, outside. So plus 5 should go out here. And if I need to go 1 hour later, if I need to move to the right, inside, and is it going to subtract or add? Subtract. All right, last page. We ready? Oh, you can't tell at home, but everyone just cheered and said, "Woo, yeah, we're going to get an A on our test on Wednesday." Turn up, period. We are locked in because we're been to turn up, period. Right? Low key. Oh, wait. I got one. So if I kept my video down here while I was filling this out, that would be low key. Low key. Okay. This young lady, Jade, I think needs a new habit. She's eating 30 cupcakes in one sitting. I think Jade should instead reach for a LaCroix. All right, let's look at how long it took Jade to eat 30 cupcakes. How long did it take her? 30 cupcakes. Jade, we need a new habit. We need a new hobby, I should say. How long did it take Jade to eat all these cupcakes? She's going to be jaded after eating all these cupcakes. Sure. How long? Come on. How long did it take to accomplish this goal? Look at the graph. What does it say?
Minutes? It took her. Wait, it's like 55 minutes.
No, it took 56 minutes. 56 minutes, 30 cupcakes. This is unhealthy, Jade. This is an intervention. This isn't just a math lesson. This is a life lesson. This is an intervention. We say, slow down. So she said, okay, she tracks her progress. And on Tuesday, decided she was going to start a minute later. Doesn't do it. You're right. What does that do? Is she still going to eat 30 cupcakes? How long? But now, when is she going to start? A minute later, and instead it's going to go to 57. So, way to go, Jade. On Tuesday, you managed to take 57 minutes. All right, so Jade's arguing with us and saying, no, it's good. I waited another minute. And in our intervention, we would say to Jade, look, Jade, This is why this is a problem. You went at the same rate. You ate the same number of cupcakes. This isn't healthy. And then Jade's would say, no, no, it was different because what was different? Started 1 minute later. And how could we tell it was going to be a minute later and not a minute earlier? That gives us 1 minute later. So we start 1 minute later, which means she's also going to end 1 minute later. And there's the graph that would show, like, I know I'm not a great artist on this, but this is supposed to be the same graph, just moved to the right. Okay, now Jade is like, well, I'm going to be a champion, and champions don't quit. And we would say, Jade, you have a real problem. Because by Friday, what did she do? She's not dead yet. She's on her way, though. For real. We're gonna have a diabetic heart attack by the next month. All right. She's going to do, what did she do? What changed? She said, I got better. I finished in half the time. It's like, girl, you need to eat half the cupcakes. Girl. And when we did clock it, we realized that it was half the time. So how long did she clock? How long did it take? How long did it take before? 56. We need to clock it in half the time, as the kids say. Hey, clock it, girl. So in 28 minutes, right? That's 28. Is she still going to eat the same amount of cupcakes? Well, sad fact is yes. So Jade, this is an intervention. Now, in order to accomplish that, so let's think about what is happening here. We got much steeper. She spread it out over some time. Now it's gotten much steeper. She took half the time. So how would I accomplish that? Well, what is time measured on? The x-axis or the y-axis? X-axis. Okay. So we need to impact the x-axis. So we're basically saying we're doing this in half the time. So we need to take, another way to think of it is she's going twice as fast. So she's doing 30 cupcakes twice as fast. So our original rate was 4 times the square root of x. She's doing it in twice the speed. So we're actually going to do 4 times the square root of 2x. So twice as fast. That's what the 2 times means. Okay. We're not going to go 2 times as high. She's not going to eat 60 cupcakes. She's going to eat it twice as fast. So we are compressing the x-axis. All right. And then we would end up with 28 minutes to eat 30 cupcakes. On God, period. Did I do all the right slangs?
No.
No? Darn. Stop recording.